Let me ask you a question. Which is larger, the number of convex quadrilaterals or the number of concave quadrilaterals? Well, there's an infinite amount of each of them, so the obvious answer is no, the total amounts are actually equal. So that question was horrible. Alright, let me rephrase that. What is larger? The probability of choosing a convex quadrilateral or a concave one from 4 distinct arbitrary points. Today, I'll explain exactly what it is and how infinity plays a role into this. So how did I think of this in the first place? Well, I was playing golf, and when I was putting, I thought of the hole and the 3 balls I was putting with. And after I hit 2 of those balls, I was just thinking, because I want to get my 3rd ball in between all 3 of the balls. I was just thinking, why do I always not get it? Why do I always get a convex quadrilateral over a concave one? And so that got me thinking. And that got me thinking about where exactly is a concave and convex. And this is where I had my first thought. So imagine drawing 3 points first. In the case of golf, I hit 2 balls first, and I imagine the hole is also being another ball. And I'm trying to place the 4th one somewhere in an infinite plane. So we want to determine where is a convex and where is a concave. And it actually works out like this. The concave region is in the center, because obviously if it's in the middle, then it's concave. But also here it's concave, because, well, this point here is now in the middle. Same thing of here. This point here is in the middle. And this point here is in the middle. Whereas these 3 regions are all convex. So now I'm going to talk about finite planes. In the finite plane, what does this look like? And the conclusion is that P of convex is always larger than P of concave. And imagine flipping each concave region so that it fits into the triangle. And the P of triangle is always smaller than the P of inconvex, not concave, for an arbitrarily large finite plane. Because if you're assuming the finite plane is literally the triangle, of course you're going to get more concave than convex. So if you assume as if you're flipping this concave region onto that side, so that these 2 lines fall onto these 2 lines now, because the convex area is, well, it's bigger than the concave area in the first place, as well, if you assume it's really large, and you draw like an arc on there to the center of the triangle, you draw an arc, and then you do something there, and you flip it over, you can actually prove that the arc here isn't it's actually smaller than the arc here, which is basically the same thing. I'm not going to get into that, but that's actually a really interesting point, and I have generally no idea how to prove it, so if someone could help prove that to me, that would be really, really helpful. And so the question is, what does it approach? Of course, I'm talking about the finite plane because that's the real world. We're experiencing things in the finite world, and that's why I get more golf balls that are in the convex region over the concave region. P over convex is actually bigger than P over concave. In the finite plane, that's what it is. But in an infinite plane, we use the same method as before. We reflect the concave and we flip it over onto that side. But this time, that P in convex, not concave, is 0. Because if you're assuming the thing extends out to infinity, infinity minus the finite region, which is this, is still infinity. Therefore, the actual difference is 0. And the P of triangle, getting the probability of getting the point in the triangle becomes like arbitrarily small, because infinity, a finite area over infinity is pretty much 0. P convex is equal to P concave. The limit of P convex divided by P concave is 1, that is. And ChatGPT tells me that because, it talks about the angles and says the angles are different, and the probability of getting the convex is different than the concave. But the number of them are equal, obviously that's infinity, but ChatGPT likes to argue that the actual area, the actual probability is not equal. But I'd like to prove it wrong here, and this is my explanation of why it is. If you look at it closely right here, this angle here is equal to this angle here. And this convex region here is merely just in this triangle minus the original triangle. So if I flip the concave region over, they actually are the exact same, except the convex region is just missing this triangle in the middle. So that's my reason to prove that ChatGPT is actually wrong, with the convex having more than the concave. But ChatGPT also likes to argue that it's in the finite plane, and of course in the finite plane, the probability of getting a convex is always going to be larger than the probability of getting a concave, although it does approach them being equal. And so the conclusion is, well, in a finite plane, you're going to get more convex than concave quadrilaterals. But in the infinite plane, the probability is the same. The probability approaches the same thing. So like if it approaches something, it's the same thing as being equal to that thing. And I'd like to have some feedback on this because, of course, I probably have no idea what I'm talking about. And I'd like some feedback to like formalize the proof, and I'd also like to know if I'm actually correct or not, because I'm not 100% sure, and because ChatGPT is telling me I'm incorrect, there's a likely chance that I'm also incorrect. So it'd be really helpful if you guys could give some feedback. Thanks.